Okay, last part here for section 6.2. I'll run through all four of these right here, right now, so that we've only got one more video to look at. Examples. Which pairs of numbers are slopes of perpendicular line segments? Remember that perpendicular line segments are negative reciprocals of each other, which means you flip it over and change the sign. So 5 and negative 1 over 5. Well, 5 is the same as 5 over 1. Is that a negative reciprocal of negative 1 over 5? Well, sure. Change the sign, flip the fraction, and you get this. So yes, these slopes are perpendicular. Question B. Negative 4 over 3. Negative 4 over 3 and 3 over 4. Change the sign, flip the fraction. Yes, these are negative reciprocals. Question C. Whoops. Question C. 6 over 7 and 7 over 6. Well, these are definitely flipped over, but 1 isn't negative. Okay, so these are not perpendicular because 1 is not negative. 1 would have to be negative in order for those to be negative reciprocals of each other. They are reciprocals, but they're not negative reciprocals. And then question D. Negative 4 and negative 1 over 4. Well, negative 4 is the same as negative 4 over 1. And negative 1 over 4, well, that again is a reciprocal, but it's not negative because these would have to be different signs. Okay, so be careful with the negatives. These are not parallel. Question 2. Determine the slope of a line segment perpendicular to a segment with each given slope. As hard as this may seem, what is the perpendicular slope to 2 over 5? Well, I change the sign and I flip the fraction. Negative 5 over 2. It's that simple. Don't think too hard. Negative 1 over 3. Negative 1 over 3. Change the sign, it becomes positive. Flip the fraction, 3 over 1. Well, we never need to write positive, and we never need to write this 1, so this just becomes 3. And I'll just erase those for simplicity. Example 3. If I can make this smaller, there we go. The slope of two perpendicular line segments is given as k over 2 is perpendicular to negative k. So we have k over 2. K over 2 is perpendicular to 1 over 3, but it's 1 over 4. 1 over 4. Well, we can't do anything with these if they're perpendicular, but I can make them equal by simply flipping. So this is going to become k over 2. If I flip and change the sign of the second slope, they're now equal. Because if I flip and change the sign, well, now I've made them parallel. So now I can very simply calculate this. Because I have one variable in a system, I can simply cross multiply and divide. So k is going to be equal to 2 times negative 4 divided by 1, which is going to be equal to 8. So k is equal to 8. And then our last example. Steps to determining whether or not two line segments are perpendicular. Determine the slope of each line segment. Is the second slope a negative reciprocal of the first? If yes, it's perpendicular. If not, well, it's not perpendicular. So 4. Determine whether SW is perpendicular to AN. SW is perpendicular to AN. So first of all, I need to calculate the slope between those two lines. So I go SW. The slope is equal to 4 minus 1 over 6 minus negative 3. 6 minus negative 3. This is going to be equal to 3 over 9, which is equal to 1 over 3. The slope for AN well, now I can see it. It's going to be 6 minus 0 over 0 minus 2, which is going to be 6 over negative 2, which is going to be negative 3. Are 1 over 3 and negative 3, are they negative reciprocals of each other? Well, if I put this 3 over 1, well, they are flipped fractions, and 1 is negative, 1 is positive, so they are perpendicular. Okay, so they are negative reciprocals. So I can say SW is perpendicular to AN. And be done. Some assignment questions right here. 6.3 is an investigation. I'll talk about that in a video, and then we'll see where it goes from there. Otherwise, you've got some assignment work to do for 6.2. Remember, the only way that you can get better at any of this is to practice, practice, practice.